All right, so we're going to come back to conditional execution in some future modules or in the very next module. But for a second, we're just going to take a sidestep and look at a new topic that will help some of our programs or help us write some more interesting programs using conditional execution later on. But it's not really directly related to if statements. And that's the idea of a random number. So the random numbers are covered in 3.9 of the text. And the idea behind random numbers is to be able to maybe call a function and have the computer return a number that is essentially unpredictable. Some random number that we can use later in our program. One of the things I'm going to build up to in this module is something like a math tutor, where we'd ask the user to add two numbers and we would tell them yes or no whether they added them correctly. And so to be able to make that an interesting program, we would want it to be a different set of numbers every time the user ran the program. So the idea would be to get some random numbers from the computer. Now the trick with all this is that there really is no such thing as randomness in a computer. The computer is a very deterministic machine in a normal sense, meaning there has to be some sort of a precise algorithm to give you any sort of output. So instead of really a random number, what the computer does, or what the software loaded on a computer does, is it sort of fools you into thinking that it's producing some random numbers. There's actually a very specific and set sequence of numbers that are generated initially, and they are sufficiently, or the pattern is sufficiently hard to follow that you really can't predict the next number that the computer will give you. So from all outward appearances, it appears fairly random, and actually there's quite a bit of computer science that goes on into making these random number sequences appear fairly random. For our standpoint, we can use these random numbers, and the software that creates them is called a random number generator. From our standpoint, it's a fairly simple thing to use. We don't really need to understand necessarily the ins and outs of how it works, but I do want to give you a little bit of an idea so you can best use these functions. So the principal function involved in all of this is the rand function. So rand accepts no parameters at all, and it's going to return back to us some random number between 1 and some maximum, and it should be random max. That could be around 10,000, 100,000. It's really not going to be a big deal to us as to what the maximum random number would be. The key part to understanding rand is that each time we call it, a new random number is going to be returned. So before we hit the code, let's just give a little bit of a background on how this really works. So when a computer starts up, it'll actually run an algorithm that generates a pre-generated sequence, a fairly long sequence of numbers that have very little discernible patterns. So we might start with looking at this as, okay, we've got 3, 5, 217, 120, and I'm picking sort of small numbers here, but the point being is that there's a sequence of numbers that they're really, if I told you the first number is 3, you really wouldn't be able to guess that the next number is 5, or that the following number is 217. So it's a randomized sequence of numbers that is pre-generated. And it's based on a couple things. It's based on serial numbers for the devices on the machine. It's based on the clock. It's based on several different parameters that are somewhat unique to your machine. So I'll say unique to the PC, right? Unique to the operating system. When you call random, and you make a function call, you need to store it somewhere, right? So you need to store that value that random returns in some variable. So we've got x over here. Random is going to go and return to you the first number in that sequence, and so it'll be 3. If I then call random again, random's going to go and it's going to return the very next number. And you can see the pattern here, right? Every time we call random, it's going to increment and return the next random number in the series. So that'll be 217. So each time we call random a new value, and it's, by the way, it is conceivable that we could have repeats. That random doesn't mean unique necessarily, but the chances are fairly slim that there'll be consecutive numbers of the same value. But each time we call random, we're going to just move from one location to another along a sequence of numbers, and if we call random enough, we'll start back at the beginning. Right? So when a computer starts, that number is generated, or that sequence is generated, and random is providing you sort of a window into that random number generator. So let's do a little bit in code with this, just so we can see what kind of numbers will be printed out. To be able to use random, we want to include C standard lib. That is not necessarily required in Visual Studio, but it is required in other compilers, so we want to get in the habit of including that. So we'll include that, and I'm going to create two numbers, and I'm going to say x equals rand, y equals rand. They're not necessarily going to be equal to each other, of course, and I'll just print them out. So when we run this, what's important to note is that before you run this program, certainly you really don't know what these numbers are going to be. You know a range, of course they'll be positive, but otherwise you're sort of in the dark what those numbers are going to be. All right, so when we run it, I get 41 and 18,467. Okay, so that sounds pretty random, and of course if we go to another number, if we print out z, and in fact we don't have to really even store it, we can just say cout random, and that'll return another number. And again, I don't know what number is coming after 18,000. There's no discernible pattern to it, so 6,334. However, notice that the second time I ran it, the first two numbers are the same. All right, so they're random in that ahead of time it would have been tough to predict them, but they're the same sequence every single time we run the program. And if you're paying attention when I'm looking at this random number generator, you can sort of see why. The second time we call, or second time we run this program, we're just going to the same numbers. Right? Each time you start the program, the random number generator is still the same, and we're going to call random. And the first time we call random, we take the first value. The second time we call random, we take the second value, and on and on. Right? So while they're random, they're not necessarily different every time we run the program. All right? And that is one limitation that we can get around fairly easily. So we got our numbers somewhat randomly, our random numbers, but because it's not really truly random, and that the same sequence is used each time on a given computer, we need to do what's called seeding the random number generator. And what that does is it shuffles, or it sort of somewhat randomizes or moves the position along the sequence that you start in. So let's just switch back for a second and rewrite that sequence. I don't remember exactly what it was, but I think we had 3, 5, 217, 37. Let's make up some more numbers. All right. And so the first time we run the program, we call random, we start here. And if we always start here, then each successive call to random will be exactly the same numbers on the same machine. It'd be different numbers on a different machine, but same numbers on each machine. when we call srand and we provide a parameter, let's say 5, what we're doing is we are causing the current position along the sequence to change and to perhaps start at 117. So now when I call random, I get this value. And when I call random again, I get this value. If I seed the random number generator with a different number every single time I run the program, it means that I'll start in a different position along this random number sequence. And if I start in a different position, the numbers will appear different each time. We're only going to call srand once for all n calls to random. So each program will only call srand to seed the generator at most one time. There's no necessity, and it doesn't make much sense to keep calling it over and over again. In fact, you'll get less random numbers. They'll be easier to predict if you keep calling srand. So it's definitely a bad idea to call that more than once. But we call this once, and then we call random as many times as we want. So the question is, well, if we run a program to seed at 5 each time, we'll always start here, so that doesn't really help us. We just get 117, 9, 6, and 21 each time. Instead, I'm going to seed it with the current time. And that's pretty much standard practice. If we seed the random number generator with the current time, sort of by definition, each time we run the program, we're going to seed it with a different value. And it'll be the second since 170, just like we saw before. We'll use the time function. So let's include ctime. We'll make one call to srand with the time. And otherwise, our program's identical, the same as it was before. However, I get different numbers each time I run the program. So I've seeded it with the number second since 1970. Each time I run it, slightly different values. However, it isn't perfect. If I run this often or really frequently within the same second, if I type this fast enough, you'll notice that it gets seeded to the same spot. If I basically run the program twice in 1 second, it's still the same number of seconds since 1970 returned by this time function, and it goes to the seeding at the same spot. So srand works as long as you're not going to call srand multiple times. That's another reason why you don't want to keep calling srand before you call the random number generator. If we did something like that, we would be reseeding it with the current time each time we called random, and the chances are you calling random, within a second of each other. All right, so it would seed it to the same location. We wouldn't want to do that. So rule of thumb is you always seed once at the beginning of your program. Now another problem with this, or another thing we can work on with random numbers, is the fact that we often want a range of numbers to be used. So if we were doing some sort of an addition problem, we might not want to ask a user to add very large numbers. If it was like an elementary school tutoring system or something like that, we'd maybe want to limit the numbers between 1 and 100 or 1 and 10. And we can't actually adjust what comes out of the random function, but what we can do is transform those values after we get them. So the easiest way to compute a range of random numbers, or to keep your random number within a particular range, is to use the modulus operator. The modulus operator will allow you to transform that value into some range that you're looking for. So let's go back here and let's imagine we've got a couple of numbers coming out of this generator. So we get 117, we get 231, 1576, and 13. Right? And let's say that, so we know these numbers are coming out of the random number generator, but we wanted random numbers between 1 and let's say 100. Okay, so we want to transform this to 1 to 100. first thing that we can do is we can do a modulus by 100 with each number. So every time we get something out of a random number generator, we're going to do a modulus operation. And we're going to mod it by 100, the base. And we know that this will come out to be 17. This will come out to be 31, 76, and of course 13. 13 mod 100 is just a remainder of 13. What we should note, though, is what's the smallest number that can come out of this transformation? Well, if we had 0, all right, mod 100, that would have given me 0. Right? So the smallest number is not 1, the smallest number is 0. The maximum number, of course, is 99. So we've transformed by taking a modulus of 100, we were able to transform all these random numbers into new random numbers, all within 0 and 99. If we want to get it to 1 and 100, we're going to do a plus 1. Plus 1 to each one. And now we'll get 18, 32, 77, 14. More importantly, to 0 will go to 1. And the 99, if we had that, would have went to 100. So now we've got the 0 or 1 to 100. The general rule of thumb is mod by number of numbers. So in this case, I had 100 numbers, so I modded by 100. If I had 50 numbers, if I only wanted 50 numbers, I would mod by 50. Then plus by minimum, the minimum number in your range. So let's look at another example. Let's say I wanted random numbers between 15 and 45. Well, what I could do is this would be, how many numbers do I have within this range? Well, I've got 30 possible numbers in the range, 30 range, and 15 is the min. So my equation will be mod 30, so the random number, mod 30 plus 15. And to prove that this thing works out, if you think about taking some random number, let's say 62. Right? If we mod it by 30, we're going to get 2. Right? We're going to add 15 to it, and that'll give us 17. That's our random number. Whoops. Yeah, that's our random number, 15 to 45. If we were to think about, well, what's the minimum number if we had something like 90 divided by 30, or mod 30, sorry, we would get 0. Plus 15, and that's the minimum number that would come out. Okay, so if we look at the maximum, let's say we take something like 29 mod 30. That's obviously going to be 29. Now, I'm kind of catching myself in a little bit of an error here. We got the 29 plus 15. That's actually going to be 44. So why aren't we hitting that 45 actually? And if I look a little bit more closely, I wrote 30, but I didn't actually think that through carefully enough. 15 to 45 is not 30 numbers. It's actually a range of 31 numbers. If you count on a number line, there's 31 numbers inclusive between 15 and 45. If we were doing an exclusive range, 15 to maybe greater than or equal to 15 up to but not including 45, that range would have been fine. But if we want to actually include the 45, we actually need to mod by 31. That's another thing to keep in mind. You need to think of the actual individual numbers involved here. So in this case, let's kind of remove that example. The largest number, if you're modding by 31, would have been something like this, 30 mod 31 plus the 15, and that would have given you the 45. So when you're coming up with that range, just keep in mind if it's an inclusive range, 15 all the way up to and including 45, think about that range carefully. It's actually 31 numbers. So most of the times that you create random numbers, you're going to use that, and sometimes it'll take some playing around with. Most of the time, the ranges are fairly easy to work with. So let's imagine, writing some sort of an addition tutor like we've been talking about already, and we'll print out two random numbers, and I'm just going to make them between 0 and 9. I'm going to keep it really, or actually 1 and 10. I'll keep it fairly simple for the user. I'll ask the user for that answer, and I'll display a confirmation if they get it correct. And I'll display a correct answer if they get it wrong. So let's first off modify this just a bit. I'll keep my x and y values. I'm going to improve the printout statement. By including a plus sign here. It's not that big of an improvement, but it's make it look a little bit nicer. I'll print out a line there and ask the user to type in that value. So if I run this, let's do our range. So we're going to be, if it's between 1 and 10, between 1 and 10, we've got 10 different actual values. Mod 10 plus 1. Store those values in x and y and print them out. Oops. Okay, we have 9 plus 2. So we're going to start we're going to ask the user for this answer. So let's have an answer and let's have an input. We're going to ask the user for the input. We know what the answer is. That's just x plus y. We can compute that as soon as we're done with those random numbers. And now I'll read in input from the user. And I'm going to say if answer equals input, cout correct. And then I'm going to say if answer is not equal to input, cout, sorry, the correct answer is answer. So one way or another, we're going to see that right answer. If the user's input is equal to the right computed answer, they'll get an affirmative. If it's not equal, we'll print out what is actually the answer. We can go ahead and test this. 10 and 6, 16, correct. 10 and 3, 3, correct. That should be 14. Let's type in 15. Sorry, the answer is 14. By the way, notice that we've got some duplicates already, 10 and 10. When we reduce the range of numbers that we are going to be left with, that doesn't necessarily mean that random gave the same number. So if we look at over here, we got 7 and 7. That doesn't mean that random returned the same number right off the bat. What it means is that the two numbers that random returned happened to end up at 7 when we did a modulus. The smaller your modulus, 10, 5, something like that, the greater chance that you're going to have some repeats. If you do a modulus by 10,000, it's very, very low that you'll have the same number each time. That just kind of comes with the territory. If you're only going if you're going to limit yourself between numbers between 1 and 10, you are bound to have a lot of duplicates. All right, so we'll be continuing to use random numbers throughout the rest of the modules to add some unpredictability into our programs and to kind of develop, sort of mini games as better exercises.